Hello, everybody. Welcome to another thrilling episode of JavaScript Jabber. I am Steve Edwards, the host with the face for radio and the voice for being a mime, but I'm still your host. And Siri thinks I'm talking to her for some reason. With me today, we have a special returning guest, Mr. Feross Aboukhadijeh. How you doing, Feross?
I'm doing good. Thanks for having me here.
Yes. For those of you that wonder how to say his name, it's think about like booking a DJ for a show or something like that. That's what he told me, and it still works for me.
I'm impressed you remembered that, Steve, because
yes,
it is pretty memorable, I suppose.
Yes. So, Feross, before we get into our lovely dark world of internet hacks and people trying to steal cryptocurrency, why don't you give us a little background on who you are and why you're famous and your company and what it does and all that good stuff?
Cool. Yeah, I wouldn't say I'm famous, but I'm happy to give you a background on what I've done to date. So I started off kind of writing open source software. That was kind of what I did for most of my career. I found the early Node.js community to be like a really welcoming and awesome place. Found my way to the early NodeConf conferences, in the one in San Francisco that Michael Rogers organized, and as well as the NodeConf EU, and just got really addicted to publishing NPM packages. Published a bunch of those over the years, some projects like WebTorrent and Standard.js. I just learned a lot about the supply chain, the way that open source software is used by companies, the way that open source development happens, and I got really addicted to it, and it was really fun. It's an amazing community. And ultimately that kind of led to me starting Socket in 2020. After seeing a ton of attacks happening against JavaScript packages, I got kind of obsessed with like trying to fix the problem. Like I was like, why do we accept that packages are just going to keep getting compromised? And every time that happens, we're just going to have to hope that we were lucky and not affected by that in some way or another. Can't we actually be proactive about this, scan for this, prevent this? And so I started a company, Socket, to do that. And now we're it's a big company now. I mean, we're like 75 people. We have a ton of big customers, a lot of companies you probably recognize, and just trying to help people use open source safely.
So just to clarify, Feross and I were talking about this ahead of time. His website is Socket.dev, not Socket.io. If you make that mistake, Socket.io is Guillermo Rausch's old library for doing WebSockets. Socket.dev is Feross's entity that helps keep supply chain stuff safe. So Feross has quite the list of recent compromises and attempts to compromise the NPM supply chain. I know that the most recent one that comes to my mind that we got hit with was the one, and we'll get to this, the Chalk library and all those libraries by that same author that got compromised with the crypto, trying to steal cryptocurrency stuff. And fortunately for us, we weren't using those libraries, so we were okay. But apparently that's just one in a string of recent compromise attempts. So with further ado, I'll let Feross take over and talk about what's been going on lately.
Yeah, sure. So we've seen a bunch of attacks over the last couple months. I'll try to give you like a high level summary, and then we can dig into the different details if that's interesting to you. So we saw a phishing campaign that started about 2 months ago, back in July, where a lot of kind of popular NPM maintainers got this phishing email that was impersonating NPM and asking them to like add 2FA to their account. And it turns out that email was actually sent from, it appeared to be sent from support@npmjs.org, which is like a real email that NPM uses. But actually it wasn't sent from there. It was just spoofed. And unfortunately, the npmjs.org domain didn't have the proper like email headers set up, DMARC and SPF headers that would have helped different email clients to know that that email wasn't legit from npmjs.org. Turns out like they send email from npmjs.com, and that had the headers set up. But npmjs.org is a real domain that NPM uses. So it was still quite convincing to get an email from that for people. So lesson learned there is like you need to set up these email headers, these DNS records that help block spoofed emails, even on domains that you're not sending email from. As long as they're like a domain that your users recognize that you use, you got to protect them with those same DNS records. So what happened is if people clicked on the link in the email, it would take you to a website that looked exactly like NPM, but it was a proxy. So it was sort of like anything you clicked on would work, and it would let you navigate through the whole site, just like you were on the real site. But the domain was off by a letter. So it wasn't the real site. And then, of course, if you logged in, it would steal your credentials. So that was something that just was going around back in July. And we kind of noticed it over at Socket because some of the folks on our team got this phishing email, and we were like, oh, this is interesting. So we wrote about it, tried to warn people about it. But nonetheless, a couple of days later, there was kind of the first like prolific maintainers that were starting to get affected by this. And that started with the Prettier project. So the Prettier package, a couple of Prettier packages were compromised, including ESLint config Prettier, which is the reusable ESLint configuration that kind of has the rules for ESLint in it that you can kind of apply to ESLint. And so that was compromised with a Windows specific DLL file. So for those that don't know, that's basically just like a kind of a compiled code file that you can run on Windows machines. And that when that ran, it would steal a bunch of system information, like your environment variables, and then it would open a WebSocket. Speaking of WebSockets, it would open a WebSocket to the attacker, and it would leave that connection open. And so then the attacker could have basically like an interactive shell. So any text that they sent over that WebSocket would be received on your computer, your machine, or your server, and it would get run like in a shell, and then the output would get sent back to the attacker. So it's like they were almost SSH'd into your system, but using a WebSocket to kind of run commands on your computer or on your server.
And that's bad, right?
Yeah, it goes without saying that's bad. Yeah, okay. So I think it was cross-platform in that way. So there was the Windows piece with the DLL file, but then it was also like it would also affect you on Mac and Linux because of the WebSocket. And yeah, not good. They also kind of tried to hide their tracks through different like anti-analysis techniques. So they would encrypt the data going across the WebSocket. So if you were like looking at the text, you wouldn't see like what was going across that socket. So that was kind of the first sort of effect of this phishing campaign, was it actually hit this popular library. Then it was kind of all quiet for a little while, for about a month there, until August, when the popular NX build system was had one of their packages compromised. And this attack was interesting for a couple of reasons, I'd say. The first reason, first of all, it was similar in that it just tried to steal credentials. So it would like search your system for SSH keys, NPM tokens, basically any file that you might have on your system that contains like a key or a token in it. It would just hunt through the file system looking for that and send it off to the attacker. But what was interesting about how they did it was it didn't just use just code to do that. It instead abused AI tools like Claude and Gemini to scan your file system for sensitive data, which is a technique that we had never seen before. So this means that it would look for Claude or Gemini installed on your system, like the CLI tool that lets you interface with these AI agents and these AI tools. And it would use them to with a prompt, asking the agent to go and like search your file system for interesting files. And then it listed out a whole bunch of file extensions in the prompt, like .txt, .log, .env, .back, just different kind of interesting extensions that could have keys or data in it that might be interesting to the attacker. And then the agent would go and find all those files and then collect them in one place that could then be sent off to the attacker. So I'd never seen like an LLM being used in this way, kind of as a like effectively that the payload of the attack is not like some malicious code. It's actually just a couple sentences in English. So that really blew my mind when I saw that.
So was that effective then? Did you find it working, or just that was the attempt?
Oh no, it was effective. Yeah, I mean, if you had to have Claude or Gemini on your system for it to work, if you didn't, it wouldn't do anything. So that was kind of the funny part, was it wasn't, it wouldn't affect you if you didn't have those CLI tools installed. So they kind of limited their reach a little bit, but I suspect they did it because it was an attempt to get past code scanning tools that look for right. suspicious code, and if it's just a string, then a lot of those scanners will skip it. That said, Socket wasn't tricked by this, because we use LLMs to look at the code, which is a newer technique, right? A lot of the sort of other security tools do static analysis on the code alone, but if you actually use an LLM to look at the code, an LLM isn't going to be tricked by a sentence. You can ask the LLM, like, what is this code doing? And it'll look at the prompt and it'll tell you. So there's, with the right prompting, that actually, it's possible for like defenders, for the good guys, to also, use these AI tools to catch the bad guys using AI tools. So it is a cat and mouse game to some extent, but I think, it didn't get past us, but I would say it was effective in that if you actually ran the code, it worked as it was intended to. Yeah.
Okay.
Yeah, so that's we're still not to the chalk attack yet, but I wanted to say one other thing about this one. So NX, I don't know if you're familiar, but it's this build system. So it's kind of an open source project. They have a GitHub repo that folks can contribute to. It's just a kind of a standard, NPM open source project like people are familiar with. And so they accept pull requests from the community. And one thing that was interesting about the way that this attack happened was it didn't use the phishing email. So that's not how the attacker got access. They used a different method. And so I wanted to talk through that because I think that the method was quite impressive. So they used a GitHub action workflow that the NX project had added to their repo, and it had some vulnerabilities in it that the attacker was able to use. And so I want to walk through that because I want to make sure people are aware that GitHub Actions are they're very powerful, they're very useful. I use them all the time, but they're also very dangerous if you don't use them correctly. And there's a lot of foot guns, like just ways that you can just think you're doing something very innocent, very, 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 that doesn't look dangerous, but it's actually like a trick. Like you're actually doing something very dangerous, and it doesn't seem that way. So the thing that they did, so they did a couple things, but the first one was they were trying to print out the PR title in the action. So they had this echo command that just said like echo PR title, and then it put the variable, into the command that would print out the PR title. The way they did that with echo, right, and by putting the variable in there, created a shell injection, which it's very similar to a SQL injection. If people are probably more familiar with SQL injection attacks, and that just means that an attacker can effectively insert their code into the command. So instead of something being treated as data, it is inadvertently treated as code and executed. And so the way you do that here is you would, as an attacker, you'd just open a PR to this NX open source project, and you'd put your attack code in the title of the PR, but you'd start it with like a double quote to sort of close off the quote that they had in their command, and then the rest would be kind of run as a command. So you could get code effectively running in the environment of the of the project. Now that is in and of itself not that interesting, because there has to be something in that environment that you want to take or you want to steal as an attacker. And so this is kind of where you get to the second part, where GitHub Actions support two ways of responding to pull requests. So they have these triggers where you say, effectively, when this thing happens, run my GitHub action, right? And so the thing that happens is a pull request has been opened, right? And they have two ways to react to pull requests that are being opened. One of them is called pull request, and one of them is called pull request target. And for many years, pull request target was the one that was recommended in the GitHub docs and was what a lot of tutorials and code samples were using. So it's probably the one that a lot of people chose to use. The problem with that one is that unlike the standard pull request trigger, the pull request target one will run the workflow with elevated permissions. And it includes this GitHub token environment variable that gives you full read and write access to the repository. So that token is just sitting there in the environment, And so if you use pull request target in your project, it means now anyone can open a PR on your project. And if they can run code in that environment, that can look at the environment variables, there's going to be a really juicy environment variable there that lets them effectively commit to your repository. So the combination of those two things meant that an attacker could put code into the title of a PR, send it to just open it on, send a PR to the project, and then that code would run. And they made that code basically look for that environment variable and steal it and send it off to them via an HTTP request. So now they have the GitHub token. They can commit to this, important open source project, even though they're not supposed to be able to do that. So what do they do with that? Well, they were trying to get onto NPM. They're trying to compromise the NPM package, but they only have the GitHub token. So this project, like a lot of projects, have a publish workflow, which is just another GitHub action that they've set up that will publish to NPM. And they made sure that the NPM publish token was only available to that publish workflow. So it was isolated over there, which is great. They did a good job of that. But now the attacker can write to the entire repository. So all they had to do is go in and they just edited the publish workflow file and just added an extra step that would, I think, print out or send the NPM token to them. Because once you can write to the repo, then you can just edit any of the workflows and just doesn't matter that the NPM token was only available to some of the workflows. They can just edit the workflow and print out the tokens and stuff. So that's how they basically stole the NPM token and then published the malicious packages. So that was a lot of information, but I just wanted to walk through it because I think, I don't know if you were following all of it or it was interesting to you, but I think it's fascinating because it's just like, you're just using GitHub Actions. You don't think about I'm going to my entire repo is going to get hacked and my NPM package is going to get compromised because I just printed out a PR title in my GitHub action. That doesn't seem like it should lead to that. So it's pretty wild.
So a couple things. One, for those who want a good example of SQL injection attacks, look up XKCD number 327, otherwise titled Exploits of a Mom. And you'll recognize Bobby Tables. Just leave that to you to look up. That's one of the few XKCDs that I have memorized, the number, that and nerd sniping. But so a question for you then. Regarding how, like you just said, you wouldn't think that a GitHub action could expose, you to somebody stealing your token. Is that on GitHub? Is that on the creator of the action to have to know the fine security details of creating a GitHub action? Or is it just the nature of, what it is that everybody's looking for vulnerabilities somewhere and somebody happened to be creative, or how do you look at that?
I mean, as with security, all things in security, it's a complicated answer. I think there's blame to be shared on all sides, but I put probably more of the blame on the design of GitHub Actions because it's not fair. I don't think it's fair to, have kind of a bad design or bad defaults and then just say, oh, well, I documented it, go read the docs. The docs tell you how not to use this. If you have too many booby traps or, what sometimes called foot guns in the design of something, then, you definitely have some of the blame on the creator of that design. So there were a few things in the design here that were non-obvious to people. I think, the fact that they were recommending pull request target for years instead of the safer pull request trigger is definitely on GitHub. They've now documented that very well. So it is all documented, but there's a lot of tutorials and guides and things that are going to still have the old information. So, and then I think the other part of the design that is probably not that obvious is, so the credit of the NX project, I was very impressed. They actually figured out that they had this shell injection vulnerability and they fixed their GitHub action 2 years before this attack happened. So from their perspective, they fixed the problem. They fixed the echo issue, and so how are they still affected, right? That's kind of another interesting part of the story. It turns out that if you have an old branch that still has still has an action on that branch, then anyone can open a PR against an old branch, right? Like when you open PRs, you can target any branch. You don't have to open the PR on master or on main. You can open the PR on something from 2 years ago if the branch is still there. And so they had fixed this issue 2 years before, but it was still lying around on an old branch. And so again, to me, that's like, I guess technically that's probably explained somewhere in the GitHub Actions documentation, but I as a security person probably wouldn't have made that connection. Like I like to be kind. I like to sort of be try to have some grace for people that are just trying to do their best to like do things right. And I think there was a lot of things that the NX team did really well here, and yet despite all that, like they were still affected. So I definitely put some of the blame on the design of GitHub Actions here.
Well, that's interesting because I don't remember when it was. I want to say within the past year, somebody raising a question with GitHub regarding the deletion of branches and whether or not they're truly deleted. And, because they're thinking, okay, I'm deleting this branch. It's gone. And GitHub's saying, no, that's a feature, not a bug. As they purposely keep old branches around if you say you've deleted them. And I was like, okay. And I can think of a time where that has been useful. Where I wanted to recuperate an old branch for some reason, and I know that GitHub isn't deleted, but at the same time, that looks like a two-edged sword in the case that you're describing, and that someone thinks they deleted it, but it's really not. And so now you got to worry about old branch you supposedly deleted, which is still around. It can be used as an attack vector. And my head spins just thinking about it. So anyway.
This also matters a lot when you're trying to clean up like an accidental commit that contains a secret or a token, and you go and you force push to try to get rid of it from the history, but then it's actually like still lying around on GitHub. So for the folks that don't know, if you know the commit hash of the commit that contains the secret, or the one that you thought the commit that you thought you deleted, if you put that commit hash into GitHub, it'll actually still be there forever. It's just immutable. Like it's just a URL that just will exist forever with whatever data you thought you deleted. So if you want to actually fully delete it, you have to contact GitHub support and basically ask them to go and manually delete it. Yeah. So even if you force push, the only truly, I think, clean way to fix it is to completely delete the entire repo. But even then you might have forks. If it's been a public repo and someone's forked it, then my understanding is that the fork actually then kind of keeps a reference to all those commits and then still won't get deleted. So, you should just assume if it's been ever in a commit and it's been pushed to GitHub, like it's public forever, even if you've force pushed over it. Like it's basically, you can't put the toothpaste back in the tube.
Interesting. Yeah, but it makes you nervous. So if you delete it, so what you're saying, and if I understand, at least for GitHub, I use GitLab in my day-to-day work. We're using GitLab, so I'm not sure if all of this carries over there as well. But so if you delete the entire repo, then say it was private and nobody's forked it, then it should be gone. But individual branches are not truly deleted within a repo that's still up.
Yeah, if the repo is up, then the commits, then specific commit hashes, if those hashes will allow you to recover the data. So the question is, how do you find that hash? I'm not an expert in this stuff, so I'm kind of talking mostly based off of some research I read that was put out by the Truffle Hog team. If Truffle Hog is like a security tool that lets you scan for tokens and secrets in things like GitHub repos, and they've done a lot of research on this area. So if you search for their blog, you can kind of find out some of this stuff. Dylan Irie is the founder and creator of that project over there, and it's where I kind of learned most of this stuff from. But yeah, I think so. I think the short version is just if you've ever pushed it up to GitHub, assume it's gone and assume it's out there, and then there is a way to kind of contact support and get those commit hashes removed. But you should still obviously rotate the tokens and revoke them if you can, and try to assume all that data is just gone, even if you do that.
All right.
Yeah, I don't know how it works with GitLab. That's another interesting question though. Yeah. So do you want to talk about the The Chalk one now. The one
let's go to Chalk. Yeah,
Chalk. Okay.
In regards to another 2FA email reset being compromised.
Yeah, that's right. That one was a similar email. This time the email originated from support@npmjs.help. So I don't know. I kind of feel like that email is obviously not legit. But that said, there are a lot of companies these days using these interesting new TLDs.
Right. And is help legit? Is that a TLD?
I suppose it is. Yeah. Let me see. Google it really quickly here.
It's a Google. I hadn't looked. There's so many. It's hard to keep track of them all. Yeah,
it's like any word. The one that really still bothers me that they made it to a TLD is .zip, because now you can
Seriously?
you can have a file name that's like .zip, and you're just typing it out, the name of it, and then it'll automatically turn into a link in a lot of programs now, and it's like not what I'm trying to do here. Yeah. But anyway, but I think, again, like the phishing email stuff, it's really effective, surprisingly effective. Even people that are security experts fall for this stuff sometimes. So I don't want to put any blame on the maintainer. The only thing I'll say is phishing-resistant 2FA would have solved these problems. And so for those that don't know, what is phishing-resistant 2FA?
I was just going to ask that.
Yeah, so 2FA is just a second factor, right? Two-factor authentication. It's just the idea that you provide some other evidence that you are who you are besides your password. Typically, you'll see things like a time-based code, or you'll see like a text, like a two-factor via a text or via another app or something like that. That's all great. It's better than just having a password alone. But the gold standard, what you really want to have, is phishing-resistant 2FA. And what that is it's basically a 2FA method that is resistant to phishing attacks. What does that mean? That means that there's no way to trick a person, a human, a vulnerable, human, to take that 2FA token and to put it into the wrong website, or to put it onto a fake website. So how is that enforced? Well, let's take a simple example of one of those methods. It would be a YubiKey. So for those that haven't seen them, they're these little, hardware tokens that you can buy.
I've used those. Yeah.
Yeah. And so what's one of the best things about those is that they will refuse to give up the key material to the wrong domain. So if you're on a fake website, you're on a fake NPM website, and you ask that, you touch the key and you ask it to provide key material, it won't provide the key material to the wrong domain. It's going to provide different key material to the attacker. So what that means is that it can't be tricked, right? It works directly with the browser to enforce that it's providing material to the correct domain, and so that's why it's awesome. The other one, you might have heard,
one of these. I've used these before. You had a fob.
Yeah.
And there's another one that I had and I can't find where it was. I would plug it into a port on the laptop and you had to touch it.
Yep.
Like USB-C type port.
Yeah. So the only it's all the real benefit of it is just that it sort of the site knows that, okay, I'm talking to the person who's in physical possession of this device, so they know that some attacker isn't, unless they stole the device from you, right? Like what they're validating is that you have this physically in your possession. But the other piece of it is the phishing resistance. So the device is smart enough to not give up the material to the wrong domain, because it's literally working with the browser to check the domain and only provide it to the correct domain. So that's the kind of power of it. The other thing you've probably seen a lot more of these days is passkeys. There's a lot of sites that are prompting you now for passkeys, and for a while I was like, another thing I have to learn, but passkeys are also really cool. Passkeys have the same property in that they it's working with either your password manager or your operating system to store this passkey, and this passkey will only ever be given up to the correct domain. So again, it's phishing resistant. It can't be tricked to, it won't get entered into a fake site. So
now, correct me if I'm wrong, but a passkey is specific to the device, right? So you can't have one key passkey that you use in multiple places, or is that wrong?
It does lock you to a device in theory, although I can, I have one password and I put my passkey into my one password. And
really? You can do that?
Yeah, you can do that. Yeah. Cool. And that way, if you get a new device, or you get I can set up my passkey once on my computer, and then when I'm on my phone, I have my one password there as well, and I can just log into the same site. I don't have to keep binding numerous passkeys on every device and do it all over again when I get a new device.
Oh, that's so yeah, because I have that same setup because we use 1Password at work, and I use it like for ADP, which is our personnel HR management stuff, and I use it there all the time with with the fingerprint on my MacBook, which is tied to 1Password, which then gets me in. But I didn't realize I could use that across devices. That's cool. Okay.
Yeah, I think you can. So I'm not sure that the standard is very complicated. There might be a way that some sites can like prevent you from putting your passkey into something that has cloud sync. But don't quote me on that. I'm not like, I just know there's a lot of complicated options, and sites can demand certain properties of the device, of where the passkey is being stored. But
okay.
Generally,
I already put it on Twitter. Feross said that passkey. I'm kidding.
No, but in my experience, I can basically put a passkey into 1Password anytime I've been prompted. So it's pretty cool. So anyway, the reason I bring all that up is just to say that like basically like the maintainers wouldn't have been able to be tricked if NPM had mandated 2FA with this phishing resistant property. So it's somewhat disappointing that this was somewhat preventable. If NPM would have been willing to kind of force this on maintainers, which is I'm not saying it's costless. Obviously, there's some cost of kind of making everybody go through this, but for prolific maintainers with access to billions and billions of downloads per week, I think it's probably it's obviously, in my opinion, a good trade-off to make those maintainers take this extra step. So what happened here was this Kix maintainer was compromised. He fell for the phishing attack, and then he had access to a lot of Cinder Sources packages. And Cinder Source is an awesome, amazing, prolific maintainer who has some of the most useful and popular packages on NPM. Powers a huge, huge portion of the JavaScript ecosystem, and so that compromise was able to allow the attacker to insert some code into those packages. In this case, the code was crypto stealing code. So it worked by hooking into the fetch API and the XML HTTP request API and various like wallet provider APIs. And so what it did was if you called those functions in your front end of your site, it would be able to rewrite the transaction data and replace the legitimate addresses with the attacker controlled addresses. So they were just effectively trying to insert themselves in the flow and like make sure that you sent the money to them instead of to your intended recipient.
Yeah, I remember when that came out, there was a bunch of them. And by the time we got notification and looked, I know that, was it Chalk? That's the one that comes to mind. I know there's some other libraries that had already had an updated version. I think they'd rolled back to a previous commit or something like that. I don't remember how they did it. And so if you installed that, then you were pretty good.
Yeah, but this was like a lot of popular packages. There was like Chalk, color packages, debug.
Right.
It's a big one that people use. I use debug. Yeah, so there's just a lot of these like low level, widely used packages.
Sort of a left pad type thing again.
Yeah, exactly. Yeah, so that was a very big one. Fortunately, it was only live for like 4 hours, but if you were unlucky enough to install during those 4 hours, you were affected. So this is kind of why like we started Socket, to be totally honest with you, is because it seems like everybody is like reactive to these things. I read about Chalk was compromised. Let me check my system. Did I install the vulnerable version or the malicious version? And then you just kind of hope that you were lucky enough to not have run an NPM update during that window of time. And it just like feels like we ought to be able to do better than this as a community, as an industry. Like we can, fundamentally the problem is we're installing code that we haven't evaluated. We haven't looked at the code that we're running. That's really what it comes down to, is we're hitting install, we're pulling code in from the internet, we're not looking at it, and then we're executing it. So that's where I think treating this code differently, treating it as something that's part of your application, that is your responsibility. It's something that isn't just a black box. It can help change this sort of risk profile here, or you can use a tool to help you, and that's what we try to help, is looking at the code for you, using a bunch of automation, a bunch of static analysis, and a bunch of LLM kind of like AI analysis to find these attacks even before anyone has kind of discovered these. Like we're scanning in an automated manner all of NPM as well as all of a bunch of the top ecosystems like the Python, .NET, Rust, Ruby, Go, Scala, etc. So then hopefully we can sort of be in the middle of that and prevent those packages from getting on your system.
All right.
So that's that one, and then there's a few more that came after that. If you're interested to
let's keep going.
Keep going. Okay.
Yeah. It sounds like I knew about that last one, the one Chalk et al. But you were telling me about the newer ones that I apparently haven't heard, so want to hear about them.
So after the Chalk one, there was another one that followed the following day. Compromised this project called DuckDB, which has 300,000 weekly downloads, and that one. DuckDB, yeah.
I've heard about that one. Yeah.
You did hear about it, okay?
Well, no, not that. I mean, just DuckDB. It's the tool itself.
Right. Okay. Yeah, and this one was the same attacker as the day before. So this was exactly the same malware that affected Chalk. So this one was clearly the same person. And then the following week, there was another set of attacks, and this kind of brings us toward the end of the story. So this one was interesting because it affected another color library. I don't know why it's always a color library, but it was a color library called TinyColor. And on the Monday of September 15th, it hit about 40 packages. And basically the thing that made this attack interesting was that it searched your system so the malware searched your system for NPM tokens. And if it found an NPM token, it wouldn't just steal it. It would actually figure out what are the packages that token gives access to. It would download those packages, the tarball, the actual code of the package, and it would insert like itself. It would replicate itself, the malware, into that package, and then publish it back to NPM. So
as a new package,
as a new version of the existing package.
Oh wow! Okay.
So if you if you were affected, you would not just have your NPM token stolen, but all your NPM packages that you maintain, that you have access to, would be infected with the same malware, so that it sort of spreads like a virus, like a worm through all of NPM. And so within like a day, so by Tuesday, September 16th, by the following day, 500 packages had been affected by this. It just spread like a worm completely through NPM, infecting like even some pretty like surprising packages like CrowdStrike's packages, which is a security company that like a lot of people use, one of the largest security companies. So it's just interesting to see how wide this kind of spread before it was killed.
So I'm looking at the blog post on your site about this one. I believe, what is it, Shai Hulud, or is that the one you're talking about?
That's right. Yeah.
Okay.
Yeah. So the malware, they called it that because of, I think, as a reference to Dune.
Oh, that's right. Okay, I did hear that. I remember that.
Yeah. So yeah, this was like the first time.
So how long was that out there before it got?
Probably like 2 days or so. It was probably like a couple days that it was out before it was caught, before it was fully shut down. Because
that's a long time.
Yeah, they kept changing the malware, like the actual payload, so that there was like 6 or 7 different versions that we were able to identify across the different packages. So they kept evolving it to make it a little bit better and fix different bugs in the worm. But it ultimately, was kind of petered out, I think, due to kind of once NPM realized, we and others had reported it to NPM. I think that they kind of helped shut it down. So yeah, I mean, it's funny because like this concept of an NPM worm had been known about and talked about for several years before this happened. Like there had been some folks that had written posts about like, oh, I could make a worm and it would take over all of NPM in a day. And there's blog posts on this that you can find where people are, good folks, like good maintainers, were sort of speculating about this and writing about this, but we'd never actually seen it happen.
Oh.
So it seems like the attackers finally like realized that they should try to do that, and it worked to some extent. I think the issue with all these things though is that they're so noisy that they end up being caught by the community or by security companies like Socket pretty quickly. And once people are aware, then we can put blocks in place for all of our customers to prevent them from bringing those in. And then once the registry is alerted and if they're on top of things, they can help shut these things down. So the real kind of reason we've been so lucky as a community that these things haven't been more deadly or more dangerous is that the attackers have been kind of noisy, I'd say, like loud and noisy, maybe a little clumsy in the way that they've done these attacks. If you were smarter, you would actually be sneakier, and you would, try to last for several weeks or months without detection. And then, and during that time kind of spread far and wide. Whereas these things keep getting shut down in a few hours. And so, yes, it still affects a lot of people. I mean, if you have a package with billions of downloads and it's live for 4 hours, that's still going to hit a lot of people. But I think it would be much worse if it had been live for weeks, right? And that's kind of what I think they're failing to do right now today.
Yeah, I can think of, not necessarily the same thing, but in terms of data hacks or intrusions, that they find that have been around for months, or, Microsoft, I think, has had a couple, and there's other ones that come to mind where they've been in there for months, and you're like, oh, good Lord, they've had time to find everything.
Mm-hmm. Yeah, totally.
So I'm just thinking the sort of a, back to your two-edged sword is like, okay, you create a product, it's a great product, everybody's using it. Now your responsibility increases with that too, to protect your users. Because I think a lot of us assume, NPM, everybody's pushing packages to NPM, it must be safe. There's not any problems, right? But you were talking about the blog post that people had written, say, hey, I wonder, if I wanted to write a worm, I could do this and this. So are those in retrospect that people noticed those blog posts that people had been writing, or was that people had been, or somehow bad guy just read, saw those and said, hey, let's try it? But was it in retrospect that people said, oh yeah, somebody's been writing about this for a while, we should have done something about it?
I think that likely the attackers probably just independently thought of it. There's
really?
been so many. I don't know. I mean, who knows? But
yeah.
I feel like this is the kind of thing that if you have the attacker mindset or the security mindset, that you think of these things just for fun all the time. Like,
right.
Like hackers are it's obviously that all the things we've been talking about in this podcast are all bad in the sense that they're all stealing data, and it's all crimes. But there's another angle by which hacking more generally is kind of this creative endeavor, where you're trying to find a gap between the written rules of a system and the actual rules of a system. So the written rules of the system say, NPM is a place you publish code, and it's legitimate, only legitimate people can publish code there, and therefore you can kind of rely on it. But the actual rules of the system are, there's many ways to get access to packages that you shouldn't have access to, and kind of the attackers and these hackers are good at seeing those gaps, and that's really what hacking is seeing these gaps or these differences between the way the system is supposed to work, the way that it works on paper, and the way that it actually works. And so I think any kind of creative mind or good hacker mind could have thought of something like this worm, and it's just a matter of who's going to think of it and who's going to do it. And so that's why there's always going to be more attacks. I mean, that's why security is interesting, really. To be honest with you, like I love it because it's always changing. You have an adversary that's evolving and changing. If you learn like architecture, or you learn, pick your whatever field that you pick, like the laws of gravity don't change. So if you know how to build a bridge today, you know how to build a bridge 100 years from now. Like it's the same constraints. Gravity is the same physics. It's basically the same, right? Whereas in security, that's not true. You have this sort of intelligent opponent who is adapting to what you do. And so it's a dynamic system. So it's kind of exciting in that way.
The term I've always used is a cat and mouse game, right?
Mm-hmm. Yep.
Yeah. You mentioned that the old blog post that it brought to mind about, I think it was 12 years ago, I was working on Drupal and maintaining some Drupal sites for an organization. And there was a bug that came out that got put in there, and it was referred to as Drupal-geddon, because it was so bad that if your site got infected, you basically needed to start over with your database and somehow, import it from somewhere else. And somebody went back in the issues history for the particular module or piece of code that got it, and found where somebody had filed the bug report that said, hey, and it all had to do with an array that was passed in and how I handled reading values out of an array. It was something super simple, just a couple characters. Mm-hmm. And they had said, okay, this issue is here. If somebody figures this out, we could be in some serious trouble. And somebody figured it out and nobody fixed it. And it ended up being just a huge thing. But, I was just thinking in terms of bug happens, somebody goes back, oh yeah, somebody raised this flag a while ago.
Right. Yeah.
But hindsight's 2020, right? In anything.
In that sense, I guess, yeah. NPM has known about this risk for a while, but it's difficult. I don't want to keep all the blame on them. I do think that there's definitely some blame, like with all things, there's blame to go around, and kind of every you can point to different places where different people were at fault. But but it's a hard problem because they're balancing usability of the package manager and wanting to make publish workflows flexible for people. It's useful to be able to have a GitHub action that can publish new versions of your package to 10pm,
right,
without having to run that locally on your system. And if you were to try to do like a 2FA there, now you can't have automation. You can't have, you can't automatically do releases when certain, when commits land and stuff like that. So a lot of maintainer workflows would be affected by a sort of a naive change like that. And then there actually already has been pushback to some. So the NPM has actually done some things in the last couple of weeks to address these attacks. They made some security changes, but even those modest changes that they're making have gotten a lot of pushback from maintainers who don't want to deal with the extra steps. And I don't blame them. It's annoying. It's just this direct trade-off of security and usability, which we always see.
All right, so we're getting close on time. So we got a couple more recent incidents.
We made it through all of them. We made it through
all of them.
Well, there's always more. I could tell you, there's probably we find stuff every day. I could tell you about something we found probably an hour ago. We're always blogging about this stuff on Socket.dev on our blog. So, but just in terms of the sort of really big ones over the last little while, I think we covered all the main ones. I don't want to get into every little piece of malware, but maybe that is itself interesting to you. I don't know, because just the idea that this stuff is actually it's not just when you see it in the news that it's happening. There is this constant low level burn of daily malware, dozens and sometimes hundreds of malware packages being pushed every day to these registries. And we're always out there looking for this stuff, trying to get it taken down, trying to protect people. Yeah, shout out to the Socket threat team for doing such a great job, hunting for these things. And
let's segue into that. Since you've given us all this information, we'll do some shameless plugging here. So why don't you talk about Socket.dev, not IO, and tell us just about what you do, big picture, and then some of the products that you offer to help you avoid these issues that we just talked about.
Yeah. So our whole mission is to help developers protect themselves from exactly the kind of stuff that we've been talking about. So we started in 2020. We've been working at this for a while. Today we find around 1,000 malicious open source packages every single week across NPM, Python, and about 8 other ecosystems that we track. So we're just trying to help developers stay safe. And there's a couple ways that developers can use Socket to stay safe. I'll mention actually the newest one, which is one I'm actually very excited about, called Socket Firewall. And this is a free product that anyone can use. It's really easy to get started with it. You just npm install SFW, which stands for Socket Firewall, or stands for Safe for Work, I guess, depending on the way you look at it. But once you install SFW, all you have to do is run your normal package manager commands, but you just prefix it with SFW. So for instance, you'd run SFW npm install foo, or SFW npm update, or SFW NPM install or yarn add. It works with everything. Works with Rust and Python and all the JavaScript package managers. And what will happen is everything will install like normal, except for if you're about to install something that's been compromised. So it's really like a filter on the packages that come in. And if we've identified that there's malware in any of those packages or threats that could affect you, we'll just basically prevent them from coming in. And we'll print a message telling you this package was blocked for blah, blah, blah reason. So it's very simple to use. It's totally free. People can just install it and start using it. And we're just giving it away to the community to like help people stay protected.
Oh, okay. Yeah. Here it's not listed on your products, but I see the blurb at the top of the page there. Yeah,
we just announced it literally last week. So it's exciting. I mean, we do have a paid version of it for people that want to roll it out at their companies. Like you can deploy it in a server fashion. So instead of it being a wrapper around the package manager command, you can actually deploy it as like a server, and then you can point your different like package managers to that server as your registry. So you can kind of set the registry to be the socket firewall, and then it'll like work in that fashion. So folks can look into that if they're interested in like using it at their company. But the free version is really powerful and like does everything that folks need to do to like protect themselves today. And I recommend that people actually alias it. So you can alias it in your shell so that when you type NPM, it just runs SFW NPM behind the scenes. And so you don't have to remember anymore. You just put that in place once and then you're just protected forever.
Awesome.
Yeah.
You can see the details on Socket.dev. For sure.
Yeah, and it's really cool. Yeah, people should definitely check it out, share feedback. We tried to make it work really, really well, and it works with NPM, Yarn, PNPM, pip, cargo, and UV. There's a bunch of different package managers it works with. So
cool.
Yeah. And then the other thing people can do is our main product. Like this is the main thing we've been doing for like, years now. This is our bread and butter is we have a GitHub app or a CLI tool that you can use to scan your projects and protect your projects. So if you're on GitHub, it's really easy. You just go to Socket.dev, you hit install Socket, and it'll give you like 2 clicks. It'll just ask you, do you want to install this on your GitHub organization? And once you do that, then all your pull requests will automatically be protected. So if we see you about to upgrade to a bad package, we'll be able to put a comment on that pull request and tell you why this package is risky or why you shouldn't use it or what would be a better alternative and all that kind of information. So, and it's all configurable. So you can go in and sort of tell it, I really care about, preventing deprecated packages from getting into our project. And then it'll warn you if you're bringing in a new package that's deprecated. Or you could say, I really want to prevent unmaintained packages from being brought into our project. And then we'll be able to tell you when someone on your team is bringing in a package that hasn't had an update in 5 years. We'll be able to print a little comment and say, hey, this package hasn't had an update in 5 years. Are you sure you want to use it? And it's up to you. You can block in that case, or you can just warn and let them decide how they want to handle it. It's really all up to you. So it's pretty powerful.
Awesome. All right. So before we get into picks, obviously we know about Socket.dev and your blog on there. Where else can people hear what you have to say or give you money or anything like that?
Just check out Socket.dev. I'm personally on X and the different social media platforms, Mastodon, Blue Sky, all that stuff. My name is just Feross, Feross. And then Socket. Socket is on there too under Socket Security. And I mean, I'll also just shout out to or let people know like that if anyone is interested in this stuff and wants to talk about security or how to stay safe while using open source, just hit me up. I'm happy to like talk about this with people, even separate from like becoming a Socket customer. I also have been a lecturer and like a teacher in the past, so I love talking about this stuff. So if anyone listening wants to learn more about like what they can do to protect themselves from these types of attacks, or just wants to like hear more about the latest stuff that we're seeing, that I'm seeing, let me know. I'm happy to kind of consider doing a talk at your company to your developer team and just talk about these issues. not like a product pitch or anything, but just talking about supply chain security. I like to do that from time to time. So if you think your company would be interested, let me know. I'm happy to help.
All right. Well, I wouldn't have any problem with shamelessly plugging your company, considering all the information you're putting out there. So
thanks. Yeah, we're trying to do the right thing, and like, you know, all of our data is public too. You know, you can go to Socket and search for any package, and we'll give all the data back to you. So you'll see all of our scores and all the findings, and whether it's safe and different risks and quality issues, and it's all open. So we're just trying to be useful.
All righty. So with that, we will move into picks. Picks are part of the show where we get to talk about whatever we want to within reason, of course. You know, books, movies, games. Chuck likes board games. Tech could be non-tech, could be whatever. I always like to say I'm the high point of these with my dad jokes of the week. So we'll start with that and then let Feross save the best for last. Well, almost the best for last. So anyway, a Roman walks into a bar, holds up 2 fingers, and says, "I'll have 5 beers, please." Roman numerals, if you're wondering. Yes.
That was actually funnier than I expected.
Few people have said that to me. An observation: humans are the only species that will cut down trees, make paper out of them, and then write "save the trees" on it. And then the other night, my wife said, "Honey, why is there a strange baby in the crib?" I said, "You told me to change the baby." Thank you. Those are the dad jokes of the week. All right, Feross, what do you have for us?
I have a few picks. One is a book I picked up last weekend called The Power of Now, which is interesting. It's about kind of the idea of like living in the moment, being present, and it's kind of like a spiritual kind of a book. But I thought it was very interesting. It's really a simple idea that like your entire life is experienced in the moment, but yet we spend so much time thinking of the past or thinking of the future. And I'm someone who spends a lot of time thinking more about the future than the past. I don't tend to dwell on things, but I do worry a lot about like what I want to do, what I want to accomplish next, like what am I working on? I like to work a lot, and so I just thought it was a very eye-opening kind of reminder that it's not a good idea to live your entire life just thinking about what's to come, but like actually take a breath and appreciate how awesome the current moment is, and so anyway, I recommend folks look at that if that resonated at all. And my other pick will be just a classic book I always go back to every few years, which is the Ender's Game series. The Ender's Game series is excellent, and even the prequels are just amazing. I've
heard about those. And what kind of book is that? Is it like sci-fi? Is it? Or what is it?
It's sci-fi. It's sci-fi. Yeah. So it's about a lot of people have read Ender's Game, I think, but if they haven't, it's basically about a kid who has to go into space and learn how to become like an insanely competent commander of fleets, so he can defend Earth from an alien invasion that's coming. The series is like kind of it goes in the future. It goes into like a really different direction, and it goes like 2,000 years into the future and follows the kid as he kind of travels through the solar system and encounters like different new alien species. And then the prequels are about kind of the earlier attacks that the aliens did on Earth, and the humans that kind of fought them. And it's just, I just like the writing style a lot. I think it's really immediate and really simple, clear, crisp, like fast moving language. It's just really a joy to read. It's like a really fun read. Awesome.
Is that it?
Am I supposed to have more than 2 picks?
Nope. Some people just have one. Some people are like, I don't have any. So
yeah, I mean, I'll add a final one, which is just a reminder for people to NPM install SFW and check out Socket Firewall, which we recently released. And please send us your feedback if you run into any problems or or you think it's awesome, or you use it at work or anything like that, let us know. It would be awesome to get people's feedback on that.
Cool. All righty. Well, thank you for coming back, Feross, and telling us about what's been going on in the web safety world, or in some cases, the lack of web safety. And thank you for listening to JavaScript Jabber, and we will talk to you next time.